All right. Would y'all like to discuss the quiz? Okay. I think I have the key here. Let's see. What was... I didn't make the key. Darn it. Okay, so you ready? Here we go. Ready? So this is a square root function. Square root function looks like a parabola that's been cut in half laying on its side. You're going to move it to the left 5. You're going to reflect it over the x-axis and then move it up 4. So I'm going to take this picture to the left 5, 1, 2, 3, 4, 5. That would put me here. Then I reflect it over the x-axis, which puts me like that. Then I move it up 1, 2, 3, 4 like this. That's what I'm looking for right there. Okay? Do it in red. Then you want to know the transformations. You just would put left 5, reflect, x-axis, up 5, up 4. Question? If we did up 4 and then reflected and left 5. Yeah, see, that order is incorrect. Yep. Well, I mean, it's not going to be completely wrong, but that's part of what, look, we want to make mistakes on quizzes, all right? We don't want to make them on the exam, all right? Now, domain, what's the domain? From -5 to infinity, including -5. How about range? -infinity all the way up to 4. So we write that -infinity up to 4, including 4. So that's that part. The other way, it's incorrectly written, but I get it. But on the test, make sure. When you're talking about an interval, you have to look at it like negative numbers come before positive numbers. So you have to go -infinity to 4. Okay, the next one, this graph, we want to find a couple of things here. So let's talk about, first thing is domain. It starts at -5 and ends never. So domain is -5, including -5 out to infinity. The range, lowest y value is -3, highest y value is infinity, right? It never stops. So this would be -3, including -3 to infinity. Where's the function negative? That means below the x-axis. That is right in here, right? That's where your function is below the x-axis. Not decreasing. Decreasing is different than negative. So it's a language thing here. Negative, you would do parentheses 1 to 4. Everything between 1 and 4. If you go to a little bit to the right of 1, you're below the x-axis. A little bit to the left of 4, you're below. At 1 and 4, what are you? Zeros. That's not negative. Yes. Well, this is an interval. How did you write it? 1 to 4? Oh, okay. But again, on the test, interval notation. Where's the function increasing? That means where's it going up? It happens here to here, and then here forever, right? So from the x value of -5 till the x value of -2, why parentheses and not brackets? Oh, sorry, that's increasing. Because I said always use parentheses on increasing and decreasing. Union with, from where? 3 out to forever. So 3 to infinity. And then the last one, what are the x-intercepts? 1 and 4. And how do we write those? With the set of braces, 1, 4, close. That's the correct way to have done that. What's that? Where? Here. We're looking at the x values, right? It's always x. The only time we ever look at y values is when? Range. Everything else is based on the x values. Okay? Well, also when you're talking about max and absolute max and min, but that wasn't on the quiz. Yes, speaking of the test, our test is a week from today, right? Yep. I made a review. Okay? So that'll get you, this will ruin your Valentine's Day weekend. Okay? I didn't think I was going to get a review in time for you, but I did it this morning. Yeah, but let me talk about it. Hold on. Okay, let's talk about the review. This is probably the most important document I've handed to you this semester, right? But let me say, the review, what it says on top here, the review is intended to be used as a guide to prepare yourself for the exam. In addition to this review, I suggest you look at homework class examples, textbook lecture notes. I want to show you something, and share something with you. This is my Cal 1 class. This was their grades on the first test. And there were 11 problems, and I might do something similar to this with you. Each problem on the test, what I did is I went through and figured out not how many people got it right, but because you get partial credit. Let me just look at this one right here, 4, okay? This is this one, 7, right here. This one was the lowest problem on the exam. Of the points that I could have awarded to the class, I awarded less than half to each student. So out of 20 points on that problem, each, on average, students got less than half those points. So that was the lowest problem. And guess what? The problem was on the review. Okay? It was on the review. Now, I changed a couple of things in it. The concept was on the review. There's no excuse, in my opinion, for something like that. No excuse. Right? If you didn't know how to do it, you need to figure it out before you come to the test. And every single problem here, I've associated to a lecture. I did a problem like that in that lecture, or it was on the review. So that's what I mean by you look at this as a guide. This is not the only thing you look at, right? You also want to look at the lectures. You want to look at what examples did I do in class. What were you asked for homework? Okay? So, but this, if you can do this, you're in good shape. I think you'll definitely pass the test if you can do this. Probably a B at least, all right? If you can do all this. All right? So let's just look at it real quick. The first one, I give you a graph, and I ask you for a bunch of things here. On the test, I may not ask you for all of that. But that gives you an idea. If you know all that, there's really not a whole lot more I could ask you with a graph. Then you go to number 2. We're getting back to stuff in the beginning here. Solving a radical equation, then solving a quadratic type equation is number 3. Difference quotient, number 4 and 5. Number 6, combining functions, adding, subtracting, multiplying, dividing. Domains of functions, average rate of change, slope of secant line. Number 10, sketch this thing, and that's what we're going to talk about today. It's called a piecewise function. Number 11 and 12 we haven't talked about. We will talk about those today, and probably leading into next week we'll have to talk about it also. Okay? So please, start working on this. You should be able to do on this everything through 9 right now. 10 and maybe 11 by the end of the day. I doubt 11, but well, maybe. Yes? Okay, so what I do plan on doing is posting the solutions to this, okay? I'll do them as soon as I can. I can't guarantee when that's going to happen. My wife's out of town, so I've got a lot of free time at home right now. So I'm able to just go and in the evenings do it. And so I think tonight I'll start working on it, and I'll post them as soon as I get them done. All right. So just be looking for them. Don't be emailing me, like tomorrow at 3 in the afternoon saying, hey, where are the solutions? You said you were going to put them up. They'll be out there. Okay. You'll have them by next Tuesday. All right. And then for sure, that'll give you 48 hours before the test guarantee. But my guess is you'll have them in the next 48 hours. All right? Okay. We need to get to the business of today, which is we had in section 3.4. In section 3.4, we had skipped over piecewise functions, and then we went to 3.5, and I said we were going to come back. Well, we're back, okay? And I handed on your desk a set of the notes for 3.4. I'm calling it 3.4b, right? Everyone have that? It's just one page. 3, 4b, piecewise, revisit it. So we're going back to it, piecewise functions. Now, the reason why I like to go back and skip it is because 3, 5 is where we learn how to do transformations, right? Shifting and moving and reflecting. So if you know that, then it makes the piecewise a little easier, I think. So that's why we're going back to this. So let's take a look at what a piecewise function is. A piecewise function is a function which is defined to be different functions on different intervals of its domain. So how many of you in here pay for your cell phones? Anyone here pay for their cell phones? Okay. There's all these different sorts of programs that they have, but I think we would all agree that your cell phone bill is the same every month. There's a base charge, right? And then depending on what you use, it can start jumping up your cost, right? If you use a bunch of data, you get into this next tier, or maybe your plan does it by how much data you use. Whatever it is, you can look at it as a function. Your cost is something, and then it changes, right, to something else, and then it changes again, possibly. That's what piecewise function is. It's a function that does something for a while, changes to a different function, and maybe another one, and maybe another one, all right? So we're pasting a bunch of functions together in creating this picture. So here's an example. I have a function f of x. It is equal to 3 different functions. The first function is negative 3x. What does that look like? It's a line. What's the slope of that line? Negative 3. What's the y-intercept of this line? 0. I would expect everyone in this class to be able to draw that line. Goes through the origin, has a slope of negative 3. That means rise over run is down 3 to the right 1. What about 0? Just a flat line, right? It's actually the x-axis. Just a flat line. And then this function is what? That's your parabola. And what's happened to it? Before it went up 1, what happened to it? The 2 stretches it out vertically, makes it more narrow. Okay, so it pulls it up. So we have a line, we have another line that's flat, then we have a parabola that's been moved up 1. But we don't just draw all those on one graph, right? If I were to sit here right now and say, okay, draw that line, looks like this. Draw that flat line, it would look like this, that's 0. And then the parabola would be something like this. Is it possible for my function to be all 3 of those? No, I mean, that fails the vertical line test. It can't be all 3. So the piecewise idea comes from the fact that this piece over here, this information here, tells you which function you use on what parts of the domain. So this is saying, look, if the x value is less than negative 1, that means to the left of negative 1, you're going to draw me the negative 3x. If your x value is negative 1, you're going to draw 0. And if the x value is greater than negative 1, that means to the right of it, you're going to draw the parabola. Okay, so let me try and see if we can visualize this. Good night. Those are the 3 graphs that I was just explaining, right? So the first interval, go back to the information here. X is less than negative 1 means everything over there, right? X is negative 1 on the x-axis, everything over there. When I'm over here, I want to draw which function? Negative 3x, which is this blue one, right? So I want to draw just that piece, right? Okay. And then I'm going to put an open, this is supposed to be a hole, right? Because there's no equal sign underneath this inequality. So when I actually get to negative 1, I don't want to be that line. All right, make sense? Then this is a little confusing. X is equal to 1. What does x equal to 1 look like? Well, it's not an interval, right? It's just an actual point, right? Here's x is equal to negative 1 is just this this line that goes through here. When I am there, I want to draw what? 0, which would be that point right there. And then, when I get to the right of -1, I want to draw the parabola, which was this green thing, right? So I want to draw, oh wait, let's do that. That's to the right of -1. Then we draw the green one. And then let me pull all that crap out of there because it's just getting confusing. That's your piecewise function. Okay? You've got the line to the left of -1, it's the line. Then when you get there, what happens when you actually get to -1? You jump down here, you draw a dot, then you come back up here, and to the right of -1, you continue and draw a parabola. Yes? You're what?
It's kind of like a memory, like muscle memory.
Okay. Sure. Sounds good. So how are we going to graph these? How are you going to do them yourself? That's the question. I mean, this is just an animation to show you how this is what it looks like at the end. How you do it is going to depend on what's most comfortable for you. So let me show you the way I would approach it. All right? This is the last thing I have here. Piecewise function is a function which is defined to be different functions on different parts of its interval domain. That's the same note I had earlier, right? I don't have anything else on this except for let's do some examples. All right? Anything else I want to say on this? Yes?
So why did you include the y equals 0 if it's like not? Like, I don't get why you drop down, but it has to.
Because, look, do you agree that this tells me, this top piece tells me, the top piece, forget it. The top piece tells me what to do if I'm to the left of -1. The bottom piece tells me what to do when I'm to the right of -1. The middle piece tells me what to do when I am -1. So we have this hole here because at -1, we don't want to be up there. We want to be down here. Got it? Okay. All right, so let's do some examples. I'm just going to pull something from the book. 3. And then maybe we'll do the one that's on your review or something similar to it. You know what? Let me do one that's just similar to the review. Something that would be more like what's on the test. Yes? Uh-huh.
You're always going to be given if x.
Yes. You will always be given all the information that you need in terms of the function. Nope. There won't always be 3. Sometimes there's 2. Sometimes there's 4. To be piecewise, you need more than 1. Yes. All right, so let's try this. I'm making this up on the fly here, so I hope it works out great. All right, I'm going to use some graph paper here. Let me define the function. So I'm going to define my function f of x to be equal to, let's just start with 2 pieces. X plus 3 squared minus 4 if x is less than or equal to 1. And then absolute value of x plus 3, no, not plus 3, minus 1 plus 2 if x is greater than 1. I'll turn on another light here for you. Or you know what, we opened those windows last time, right? And it worked okay? So do you see what I was saying, why we've come back to this section instead of doing it ahead of time? Because those 2 pieces that you have, right, the top piece and the bottom piece, are the functions you should know how to graph, sketch real quickly, right? Using transformations. So I realized that this right here is a parabola. It's been moved to the left 3 and down 4. Then this one is the absolute value function, which looks like a V. It's been moved to the right 1 and up 2. Okay, so I'm going to draw a quick sketch real quick. This is not going to be my final picture. Quick sketch. So start with my parabola. Move to the left 3, 1, 2, 3, down 4, 1, 2, 3, 4, and I would draw a U that would do something like this. Again, it's a sketch. I'm not being real particular right now on where things hit. I'm just drawing a real quick picture. So there's my parabola, and then my absolute value function is moved to the right 1, and then up 2. And then at that point, I draw what? A V. Now, where is it that the function is changing? Where's the switch happening in the domain? At 1, right? To the left of 1, I'm the parabola. To the right of 1, I'm the V. Yes? So I'm going to come in here with a line. I don't want you to confuse that line with, it's going to be part of your graph. I'm just using that to help you see where I'm splitting the number line. That's where 1 is, right? To the left of that, I'm the parabola. To the right of that, I'm the V. Got it? Okay. What we need to figure out then, I think from this picture, can you tell that the V is going to come in and actually hit that line right there? So I know right now what that's going to look like to the right. But to the left, the V is going to be cut off, and the parabola somehow comes in here somewhere, doesn't it? It would be nice to know where it comes in. So how can you figure out where that parabola would actually come into this yellow line? Let x equal 1. Just plug 1 in to this piece right here, and it would tell you where you would be if you were on that parabola. Do you agree? So I think what I'm going to do is I'm going to try and do a better graph here. Now I'm ready for like my final graph. In fact, I think I'll even go to a different graph paper. I don't need as much as I thought I would. Okay, so let's get the V taken care of first. I went to the right 1 up 2, wasn't it? Right 1 up 2, that was here. And then it went like this. Now I put it as an open hole for right now, all right? Remember my yellow line that's coming through here is like this. My parabola, I know that the vertex was what? 1, 2, I say vertex, we haven't talked about that. 1, 2, 3, and down 1, 2, 3, 4. So to left 3, down 1, 2, 3, 4, like this. I know it curls up on the right, on the left and to the right. I'm going to figure out where it would come into this yellow line by plugging 1 into the parabola. So please plug 1 in here, and what would you get? You get 4 in here, square that, you get 16, take away 4, you get 12, don't you? Which is going to be way the heck up here. Don't worry, on your take-home review, everything fits on the graph real nice. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, damn it, Robert, 11, 12 is up there, okay? So it would go and curl in here like this, way up here, like this. And then I'm just going to say 12 is up there. Let's just say that's 12 right there. That's what it would look like. And then make sure your parabola comes in this way, like this. Let's just take a poll. Tell me if you're okay with what I've done up to this point. Okay, so that's what we need to talk about right now. Right? Notice I left this open, and I left this one open intentionally. I need to ask myself what is actually happening at 1. Okay? Well, up here it says if x is less than or equal to 1, you want to be the parabola. If you're greater than 1, that's not equal, then you want to be this. That means at 1, I need to be the parabola. So I should put a solid dot on the 12. No, I wanted to see if you're good up to that point, like with what I had. When you draw these, I recommend you always put the holes and come in later and figure out where they're filled in and where they're not. The thing is, you can't have them both filled in, right? Okay. That's right. Now, could you have them both holes? Yes. And that would look like this up here if you took away the equal underneath it. Then neither one of them would be defined. You would have holes on both. All right. All right. Now, would you like me to do the one on the review, or you just want me to make up a different one? Make up one? I'll make up one for you. This time, I'll try and make this one work out a little nicer so it all fits on the graph. So, yeah, it's a -2. This one right here? Yes. Did it look like a Z? I strike my Z's, but what else? I want a third one here. We've got a line, we've got a parabola. How about a square root? We'll throw a square root in here. Now notice I did not write if after these. Do you see that? I didn't put if this. What did I do on the review? Did I put if? I did put if. I'll put if on the test. You should just be comfortable that in some books they don't write if, they just put a comma and they just write down the information. So this means this, and x is less than -2. Okay, let's draw this thing out. Try and do a quick sketch first. My first one is what? Line y-intercept is 4, which is up here, and my slope is what? 3. So from this point I should go 1, 2, 3 up and 1 to the right, correct? I'm going to draw it backwards here. 1, 2, 3. Like this. Does everyone agree that's the line? Now, I drew it to the left more than I did to the right. Why? Why did I draw it out to this side instead of really caring about this side too much? Because this is what it's supposed to be when x is less than -2, right? So that means -2 is right here. Do y'all see that? X is -2 is right here. It's supposed to be this line when I'm to the left of that. Questions? All right, now let's draw the middle one. What is this picture right here? Parabola, it's been moved. Well, first it's reflected, right? Over the x-axis, so it's down, and then it's up 6. So 1, 2, 3, 4. I thought I said I was going to do it where it all fit. Let me do this. Cheat there a little bit. Okay, so my parabola is going to be moved up 6, but it was reflected over the x-axis. So 1, 2, 3, 4, 5, 6. Here it is. And this thing goes down like this, and then down like this. To the right comes like this. Where's my next transition from one function to the next happening? So -2 to 1. So let me highlight 1 here. 1 is this. And what am I supposed to draw? What's the last thing I'm drawing here? Square root. It's been moved left 3 and down 1. So I'll do this one in blue. Square root to left 3, 1, 2, 3, down 1. Looks like this. And goes something like this. Again, I'm kind of guesstimating. I mean, this looks like a mess, doesn't it, kind of? I mean, so let's talk about, I'm going to highlight in blue where my function's supposed to exist. I'm supposed to be this line when I'm to the left of -2. That means this piece right here, right? Then once I get between -2 and 1, I'm supposed to be the parabola. So that's going to be this parabola until I get to here. And then once I get past 1, I need to be the square root, which would be this part right here. Do you all see that? I mean, that's what I need. So what's interesting to what interests me now is trying to figure out where these transitions, what's happening at these transitions. Okay, let's see how you feel. I'm looking at your faces, and I'm not sure about it. We don't know those yet. We need to come up with where they actually switch from one to the next. Yes. Oh yeah, the review is not the test. You'll have room. I mean, I'll give you an entire blank page. I'll have the problem on top, and the entire page will be blank with a little graph on the bottom. Yeah, I was just trying to get it all to fit on one page so that your review wasn't 8 pages long. Okay, so I'm going to try and go and get my final picture here. Whoa, didn't mean for that to happen. All right, so what I recommend you do at this point is take a look at your transition points. -2, right? -2 is the transition between these two functions, isn't it? Just those two. Yes? So what would happen if you plug -2 into this one? Where would you be? -2 times 3 is -6 plus 4 is -2. So when you plug in -2, it spits out -2. I'm going to draw that on my graph. I'm going to plot that point. -2, right? -2, what? Yes, -2? 2, 3. Man, something's up with my graph right here. 1, 2. Let's just draw it. -2, -2. It's right here. I'm going to put it as a open circle there. And to the left of this, I'm going to draw what? The line, and what was that slope of that line? It was 3/1. So you can go backwards, right? To the right, 1, down, 1, 2, 3. Grab that point and just draw it like this. We kind of knew that's what was going to happen, right? Coming out the left side there, it was going to be that part of that line. Okay, now the parabola. What's happening over here when this parabola comes into that yellow line? That's what happens when I plug -2 into this. What's -2 squared? 4, but then make it negative. So -4? Got to get that right. -2 squared first. -2 times -2 is 4. Then you put the negative that's in front of that, which makes it -4. Then you add 6, which gives you 2. So I'm going to go over here at -2. I'm going to go up 2, and I'm going to put a open circle there. Where is the top peak of this thing, this parabola? Where did it happen? 6. So 1, 2, 3, 4, 5, 6 is right up here. So I know my parabola came in like this. You following this? Okay, now the next thing I'm interested in is the transition that's happening at 1, right? Okay, so let me look at those two, these two pieces here. So let's talk about what would happen if I plug 1 into this top one. What would I get? So 1 squared is 1, and then 5, we get 5. So I'm going to go over here to an x value of 1, and 1, 2, 3, 4, 5 would be here. I'm going to put what here? Open. I'm always going to use open. Why did I use solid here? That was part of the parabola, right? I mean, that was inside the interval. It wasn't where the boundaries are, where it's switching. Okay, what is the square root function when I plug in 1? So you get 1 plus 3 is 4, square root of 4. 2 minus 1 is 1. So I'm going to go put down here at 1 circle. Now, I know that the square root comes out the side like this, and I can finish off that parabola that came back down to that point. Yeah, now I've got all the pieces. I'm not done until I fill in the dots if I need to. Y'all okay so far, though? Okay, let's fill in the dots. How about at -2? Am I this at -2? No. Am I this at -2? Yes. So at -2, I want to be the parabola. So come over here. Here's the parabola at -2. I'm going to fill that dot in solid. How about at 1? Am I this one at 1? Am I this one at 1? No. So what's happening at 1? Just stay open. It's undefined. So you just leave them. That's your final answer right there, that picture. Any questions? Let's vote if you're okay with that or not. I would recommend sketching it. You don't have to. I mean, like, if someone gave me the problem, I wouldn't sketch it. But that's only because I've done enough of them. You know what I'm saying? Yeah. Yeah. What you can't do is just type them into your graphing calculator and try and draw me what your graphing calculator has. Although I would. Yes. And restrict your domains, yes. Well, I don't know if you can do separate domain restrictions for each graph. You can do them one at a time. All right, that's it. That's all that's for this section. All right, so see how that goes with the homework. You can do those homework problems now. Remember I had said to skip the homework problems on 3-4? I had only told you to do 9 through 16. Now you can do the other problems on 3-4. It's on the schedule. Oh, 25, 27, 30. There's a bunch of them. Yeah. But when you're doing your homework for this section, when you get to the piecewise ones, use the test review as the guide as to which ones to really concentrate on. All right. I hope that was sufficient. Wait, hold on. We had a bunch of no's. Hold on. What happened? I said, are we okay? So anyone have a question? Come on. Too shy still? Just going to say, no, I don't get it, but all right. All right, we're going to move on. The next section we want to look at, we're jumping now, okay? We are out of Chapter 3. We're moving to Chapter 4. And I handed these notes out a while back. You should have these. We're going to focus now on one specific type of function. One specific type. And it is called a quadratic function. We've already dealt with this. Parabolas. We're going to investigate these in more detail. So let me try and motivate why it is that we would be interested in these parabolas and knowing more about them. Now, let me do something. Who's going to be my volunteer over there? Go ahead, sir. There you go. Go stand up over there. All right, you ready? You can catch, right? I want everyone to watch this marker. I'm going to throw it through the air, okay? All right, throw it back. Just look at the shadow on the, whoa. All right, go ahead. Okay, that's good, thank you. If you were to take any object on a planet that has gravity, Earth has gravity, and throw it through the air, the path of the object through the air is a parabola. Guaranteed, all right? It's not linear, right? It's not a line. It's not some other function. It's not a square root function. It is a parabola always. And so if we're talking about a parabola, then we would be interested in knowing things like what's the highest point on the parabola, right? That would tell you how high the object went. And even more importantly, maybe for you, is wanting to know how far it's going to go if you throw something through the air. So if you think about this visually, if I have something that I'm going to throw through the air, right, it leaves my hand, it's off the ground, it leaves my hand, right? So that's why this is raised up off the x-axis. The thing leaves my hand, it travels in a parabolic path, and then it hits the ground. The distance from here to here is the distance it traveled, yes? But this point right here corresponds to an x-intercept of the graph, doesn't it? So if I knew that x-intercept, I would know how far it traveled. Now, this point up here was the point that we would shift around, move up and down, right? That point right there would represent the highest point, right? The y value, right, this is a point, I'm going to call it xy for right now. The y value would tell you how high it was. The x value would tell you how far out it was when it reached that height. Okay? Now, why would this be important? Let's just say that you have, I don't know, a castle. Please do not be jealous of my artistic abilities here, okay? Let's say there's a castle. Wow, that's terrible. Okay, I'll just make it two-dimensional. That's a castle from the side. See it? Those are the towers, and, well, here, I'll just put little towers on there. Okay, there's a castle. And let's say that I just have the desire to storm that castle, kill everybody, take their food and their wealth, and claim it as part of my own civilization, my own, nation, right? Man likes this, doesn't, right? We like this over history. We love to go and take other people's shit and kill people that don't agree with us. Okay, so if you're going to do something like this, you could create some sort of weapon that would lob stuff at the castle, like catapult, right? And if you were really thinking about it, you could just start lobbing shit at the castle, and who cares where it hits? Eventually, it's going to hit. Who cares? Or before you even get to the castle, you take your catapult out into the field, and you start to experiment with it and see how far it's going to go, and start making calculations, and so that when you get there, you know how far away you need to be, how you need to aim it, and if you launch it, if it's going to be parabolic, first of all, is it high enough to get over the castle? And if so, will it hit, or will you launch it too far? Right? These are all parabolas. The more you know about the parabola, the more accurate your shots are going to be, the quicker you can, instill terror into these people and whatever, right? Get what you want. Now take that, fast forward that through the history of mankind. Now we have, bombs that we drop and you just let them go and they go find the target and go get it, right? But that's all because mathematics and engineering has grown to that point, right? So in a course like this, what I'm trying to get you to see is that the study of a parabola can motivate other things. I always like to give the demonstration of war because it's universal. But then there's more things that are a little more friendly. Like, let's say you live on a planet that's round. Okay? And let's say that you want to stand over here and you want to communicate with somebody over here. You can't see them. You can't hear them, right? So how do we communicate with this person? Dig a hole. Good luck. We launch something up into the air called a satellite, right? That's my satellite. Thanks. Again, please don't be jealous if you want to know where I took my art courses. And then what do? We electronically beam a signal up to this, and then it comes back down, right? And we send it back down that person. We use satellites to communicate with each other. Well, when we send out that signal, I don't have to aim at the satellite. I don't have to be like, where's that satellite? Where is it? All I do is I just send my information out everywhere. So how does the satellite catch it? It has a dish on it, right? That's a dish. You've seen these dishes on the sides of people's houses and apartments and stuff, and right, these dishes. That's a pretty good dish. Let's not lie, okay? That's a pretty good dish. All right. If you take that dish and you cut it in half, right, and look at it from the side, it would look like this, wouldn't it? Yes? If you just cut it in half, look at it from the side, the cross section would have this curve and this thing coming out in the middle. Okay, this is a parabola. It's not any other shape. And the reason why it's a parabola and that it works is because a parabola has a very, very unique feature in that if you were to, let's talk about it like physically. If I threw something at that blue wall, like a tennis ball, I shot a tennis ball at this blue wall, it's going to hit and bounce, right? Well, with a parabola, because the parabola has certain curvature to it, it will bounce exactly to that point. And if I throw a ball over here, like this, it will bounce to the same point. And no matter which way I throw the ball, where the ball comes from, it will always go to that point. And that point is called the focus. So when you want to receive a signal, so this person sitting here sending their signal out everywhere, you have a dish up here on the satellite that's saying, okay, your signal's out there somewhere. I'm going to concentrate your signal down to a single point, and I'll be able to read that. Does that make sense? But the only way you can do that is with a parabola. So how did we know that a parabola would do this? Well, we had to study them, right? We had to understand the functions more. So I hope that gives some sort of motivation, or like, why would you want to investigate a function further? And while we're at it, yeah, I can't avoid it. I'm sorry. I just have to apologize. It's just me. I can't do anything about it. If I were on Earth and I were to take a gun and I were to shoot it, right, aim my gun horizontal to the ground and shoot it, what would happen is the bullet would come out, right? It would start falling immediately. Eventually, it would hit the ground. Yes? Okay. If I take a bullet and shoot it out of a gun and I drop a bullet at the same time, so one of them's shot, the other one's dropped, which one hits the ground first? They both hit at the same exact time. So the horizontal speed of this bullet does not affect how fast it drops. So, well, that was an experiment, but they both hit the ground at the same time. In fact, I helped my stepdaughter do a science project this year where we shot Nerf darts out and we timed how long it took, and it was the exact same time. It's a pretty cool experiment. So you can do it experimentally. It's been shown they take the same amount of time. So it's a parabola though, right? It's a parabola. But imagine that you shoot it so fast, so the bullet comes out so fast that as it starts to fall, the Earth actually starts to curve away from it as it falls. So it's trying to fall, but as it falls, the Earth is curving. Then what you get is what? Orbit. You get orbit. You get an orbit. You get a continuous falling. And so when they put these satellites up into space, they launch them into space. They get them to a certain speed. They know what that speed is. It's all calculated. And then they turn off the engines and let it go. And it just goes around. Okay, so that's what orbit is. Off the subject there, sorry. All right, piecewise, we're done. Here we go. So let's get back to the quadratics. We are going to study these. Why? Because everything I just showed you. There's a lot of interest in it later. Yes? Extra quadratic functions. Look in that filing cabinet back there. They're on the third row down, I think. They're all mixed up. Okay, so a quadratic function is usually given in one of the following two forms. F of x equals ax squared plus bx plus c. I think everybody has probably seen that before, right? That's called what we're going to call in this class the expanded form. Then f of x equals a plus x minus h squared plus k, where a, h, k are numbers, a is not 0. This is called the standard form or the vertex form. This should also look familiar to you. That's a line. Look, if this is a parabola, right? In this k, this h represents a shift left and right. The k is an up and down. The a is going to tell us if we're flipped over, right? X-axis reflection. So we've done things like this. Our goal, though, is to be able to graph a parabola, not like we did before, where it's just like move it, do it, flip it, done. We want as much detail as we possibly can with this graph now. Okay, we want a lot of things labeled. So with quadratic functions and parabolas, they all have the following characteristics. They all look like U's, right? They either open up or down. The number that determines that is A. If the A here is positive, it opens up. Same with this one. If A is positive, it opens up. If A is negative here or here, it opens down. So that it's real easy to tell if a parabola opens up or down by just identifying that number. Then, they all have a vertex. The vertex is what we call the highest point or the lowest point on the graph. So if the parabola opens up like a smile, you'll have a lowest point, won't you? If the parabola opens down like a frown, you're going to have a highest point. But all parabolas have one of those two, highest or lowest. Okay, the point where that happens is the HK. Why is that? Wasn't the H our left-right shift, and the K was our up-down? So somehow the number here and the number here tell us where we are, like where the parabola was moved to. So it identifies that vertex point. They all have what's called an axis of symmetry, which would be a vertical line. So if I were to come here and just draw a real quick picture of a parabola that looks like this, this would be my vertex. The axis of symmetry is an imaginary line, okay? It's not part of the graph. It's an imaginary line that goes right through the vertex. And they call it the axis of symmetry because if you flip this left side and reflect it over that dotted line, you get the right side. So it's symmetrical, mirror image over that line. All parabolas have that, axis of symmetry. They all have a domain of R. Think about a parabola, right? It's drawn to the left and right forever. The domain is everything. All parabolas. They all have a single y-intercept. Think about that. Your graph. Is there any way to draw a parabola where it hits the y-axis more than one time? No, not unless it opens sideways, but that's not this class. Go to pre-cal, your parabolas, you'll be able to open them left and right too. Right? But for this class, we have to have a function. So think about a parabola that opens sideways is not a function, is it? Okay. Yeah, that wouldn't work still. How about x-intercepts? Does the parabola have to hit the x-axis? No. You could have this case where what? It doesn't hit at all. You could have this case where it hits what? Twice. Could you hit once? Yeah, put the vertex on the x-axis so you could have one. So there are three possibilities for x-intercepts. You could have none, one, or two. Agreed? Okay. So here's some examples I wanted to show you. Oh, no, I don't want to mess with that one. Okay, so let's take a look at this. This parabola opens up, right? So A should be positive. Has two x-intercepts, has one y-intercept. I have the two different forms written down here. Take a look at this form right here. So a is 1, right? A is 1. X minus 3 squared. So this means shift it which way? Right 3 and then down 4. The expanded form, where do you think the word expanded form comes from? I'm going to take this right here. Let me take this right there and let me write that one down. It was x minus 3 squared minus 4. Yes? That was my function. In expanded form, all you have to do is FOIL this out. Right? Just multiply. What is x minus 3 squared? It's x minus 3 times x minus 3. And then just do your little FOIL game. It's not a game. You know what I mean? It is. Collect all your like terms together. Plus 5. So that's it in the expanded form. See how it's pretty easy to go from this standard form to the expanded form? You just multiply it out? All right. So this just shows, if I move things around here, how the expanded form changes. It's very difficult to see from the expanded form the vertex. Let me get back to that. From this right here, you can tell me what the vertex is, right? This plus 4 meant to the left 4, so you know that the vertex was what? Negative 4 was the x-coordinate, and then the y-coordinate was what? Negative 4 from this. Can you tell that from this? From the expanded form, can you tell where that vertex is? No. So there's a challenge that we're going to be presented with there. How do you figure out what the vertex is if someone gives you a parabola in expanded form? So this one says convert from standard form to expanded form. You're going to multiply this out, distribute a -2, and add 8. I'll let you do that on your own. I just did that just a second ago with a different example. So let's try this one, though. Can we convert this into standard form? Let's do it. Are you all right? It seemed like I lost you, all that talking about killing people and castles. You seem to like you've turned on me or something. Sorry, did I upset you? Just stating the facts. Man, we love killing each other, though, don't we? Love it. It's our favorite pastime almost, right? I mean, think about science, man, has been pushed by our need to be more efficient in killing each other, right? Nuclear technology wasn't because, you know, let's find other ways to power our homes and not use fossil fuels. No, it's like, let's figure out how we could kill a bunch of people really quick. Yeah, who cares? Right? I got the biggest gun. All right, so let's get this into, this is what form? Expanded. To go to the standard, you have to use completing the square. So we did that, yes? We talked about this. How do you complete the square on something? First thing, you have to identify, did we talk about completing the square? Yes, okay. You have to identify the number in front of x squared and make sure it is a 1. It is not, so what do? Factor out a -2. But factor it, that means it's still there. It's just going to be pulled off. And it's peeled off of everything, right? You could, yes. I just took it from everything. All right, what's next in the process? Identify the coefficient in front of x. Remember I came up with 2 numbers from this? I took that 6 and I divided it by 2. and it's always 2, right? And that gave me one number, which was 3. Then I did the same thing, but this time squared it, and that gave me a 9. And these are 2 numbers that I can use for the completing of the square process. Does that look familiar? We did, right? But I did it in class, didn't I? Okay. So very critical next step. Add a 0. I was in my Cal 2 class yesterday, and we had to complete the square on a couple of problems. Like while we were doing the problem, we had to complete the square. And there were a lot of students that had never seen the adding the 0. They had been shown that thing where it's add to both sides of the equation. Yes? No? There's no equation here, okay? So we are going to realize right now we have a hidden 0 right here. Here it is, plus nothing, plus 5. You don't have to write this, okay? I'm just trying to show it to you to make sure you understand what we're doing. But instead of writing 0, I'm going to rewrite that as a what? 9 minus 9. Okay, so now I'm rewriting, and I'm bringing everything along for the ride. If my hand hurts, I just push through the pain, right? It's okay to keep writing all this information. It's good notation to keep going line to line. All right, so this piece always goes in here to replace your 0. That guarantees the first 2 terms, or first 3 terms, sorry, will factor, guaranteed. I'll have the negative 2 out here still. I did a bracket last class, didn't I? Where? I pulled negative, right? I pulled negative? I pulled a negative out. So last time I used a bracket to represent this, but because these 3 turn into something squared, right? It's x and then plus 3. The plus 3 came from this 3 right here. And then what do I still have over there? These 2 together, which was minus 4. And now distribute your negative 2 through, and we'll be there. Negative 2 times x plus 3 squared, then what? Plus 8. The negative 2 multiplies times this parenthesis thing, but I can't put the 2 inside here, right? Because it's squared. I can't touch it. So I just slap the negative 2 in front of it. Then the negative 2 has to go through to that negative 4, which becomes my plus 8. That's standard form. A is negative 2. K is 8. And we must be very careful with H. H is the one that's tricky, that people mess up on. H is always going to be not this number, but the opposite of that number. H is negative 3. Because remember, a plus inside really meant move which way? To the left 3. So my vertex moved to the left 3. That's negative 3, not positive 3. Your K is just what you see there, and your A is always just what you see there. Your vertex will always be... What? Negative 3, 8, yes. If I don't have to do this, but if I wanted to, here's what I could say. Here's my vertex, right? Negative 3, 8. And this thing opens down. I know that much right now, don't I? Question? No? You got it? Okay. H is always opposite of what you see. So if this was negative 3, H would be positive 3. All right, can you please let me know if you're all right with that, completing of that square? All right. Now, completing of the square is convenient. I shouldn't say convenient. It's a good skill to have. But when it comes to sketching quadratic functions, all right, I usually do not use the completing of the square, as you're about to see. So More converting standard form. There's a shortcut that we can use to get to the standard form from expanded form. And it is a formula that allows us to compute what h and k are without actually having to complete the square. And the formula comes from calculus. So if you ever take calculus, hopefully your instructor will show you where this formula comes from. The formula is this. If you want to know what h is, you're given expanded form and you want to go to standard, you figure out h by computing negative b over 2a. Then, after you do that, you plug that answer into the function, and that gives you k. I think if I just demonstrate this, you'll see what I'm talking about, okay? So let's do this same exact problem that we just did using the shortcut instead. Sound fair? What was it? Minus 12x. Okay, remember, what we're trying to get is this. Our goal is to get it to look like that, right? Is there anything that you already know? I know what a is, don't I? It's negative 2. So I know that. So all I really need is to figure out what h and k are, right? If I can figure those out, I'm done. So I just said you have a formula for h. The formula for h is this. You take negative b and divide it by 2a. What's b in our problem? Negative 12, right? So b is always the number in front of x squared. I'm referring back to the standard form. Where is it? Here. Standard form, ax squared plus bx plus c. B is always the number in front of x. C is always the number by itself. Bless you. All right, so for us here, what's negative b? That's the opposite of b. B is negative 12, so the opposite of that is positive 12. So I put positive 12 over 2 times what was a for us? Negative 2. So this is 12 over negative 4, which is negative 3. That's what h is. H is negative 3. Okay? Now, to figure out what k is, all you have to do is take that negative 3 and plug it into the function. So what function am I plugging this into? This right here, right? So I'm doing negative 2. I'm plugging negative 3 in here, so squaring it, minus 12 times negative 3 minus 10. So just got to be careful with signs here. Negative 3 squared, 9 times negative 2. Negative 18 is that first term. Then I have negative 12 times negative 3, 36, and then minus 10, which is 8. Should be 8. Positive 8. Negative 18 plus 36 is 18. Take away 10, 8. Look at that, negative 3 and 8. So if now we go and write the function in standard form, we knew a was negative 2. Now I'm supposed to write what in here? X minus h, right? So x minus, what was h for us? Negative 3 squared plus k, what's k for us? 8. And just make that double negative inside the parentheses a plus. And that should match what we had before, right? That is it. Yep. If it's an expanded form to start, to go to standard form, this is a very quick way to get there. Whatever you want. I've never met a student who enjoys completing the square more than this, though. Yeah, I don't care. Nope, I won't force your hand. All right. So, with all that said, it's time to get to the main idea of today, which is how do we graph quadratic functions? This is a set of steps. I haven't decided if you're allowed to have these steps on the test or not. This is the way, when I ask you to sketch a quadratic function or graph a quadratic function, here's what I expect for you to do. First thing you do is make sure what you're looking at is a quadratic function, or else none of this applies, right? Then determine if it opens up or down. How are you going to do that? Just look at what A is, right? Okay. Then you're going to find the vertex. How are you going to find the vertex? Well, if it's in standard form already, you'll have it, right? If it's in expanded form, you'll do what we just did. Use the shortcut. Would you mind opening? Thank you. Y'all okay with that? So you'll find the vertex. Now here's a step I've never seen a textbook do this. I've never seen another instructor do this. So this is just my thing. I don't know if, I think you'll like it. We'll see. All right. I recommend after you get those two pieces of information, the up and down and the vertex, you do a very quick sketch. Right? Because what you'll know from a quick sketch is where this thing is, right? And if it opens up or down. Won't you? Isn't that enough to tell you how many x-intercepts you would have? Okay, so that's what I like to look at first. I do a quick sketch to determine the number of x-intercepts. If I have x-intercepts, I actually have to set the function equal to 0 and solve. That might require factoring, quadratic formula, square root property. It's a quadratic equation. You have to solve it, all right? If you don't have x-intercepts, then you just skip this step. You don't have to worry about them. Don't go trying to solve for things that you may not have. After you do that, you find the y-intercept. So you plug 0 into the function. After that, put all the information together. You draw a nice curved-looking U, and you're done. Shall we go easy, medium, hard? What do you want? Medium? Let's go medium. Medium? Okay, we'll vote. Okay, how many of you want the medium one versus the hard one? Medium, yes. Hard, no. Oh, it's a race. Dun, 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 dun. Don't do that to me. Okay, I'll do the medium first. I'll do the hard one, okay? But I'll just do the medium one first. Okay, stop voting. All right, 4x squared minus 2x minus 1. We good? Here we go. Messy. So it's 12:24. Just turned 12:24. Let's see how long it takes us to do this. I'm going to move quick, so ask questions if you got them. What is the first step, part A? Do I have a quadratic? Okay. You might even want to put what form it's in. Expanded, right? I'm just going to jot that down. You don't need to. Part B, what do? Does it open? Nope. I'm going off of my notes. Part B was up or down. So does this open up or down? It opens up. Why? What's positive? What is A? Okay, 4. Yes. Okay. We're all on the same page. Yes. So it opens up because the A is 4. All right. Now, part C, vertex. Since we're in expanded form, how would you like to go find the vertex? Shortcut? HK? Formula? Okay, the formula for H is negative B divided by 2 times A. What's negative B? Positive 2, right? Since B is negative 2, you take the opposite. So it's going to be positive 2 over 2 times what? A. What's A? 4. What's that? 1/4. And I'm going to put here that's also 0.25, although I do not encourage you to put the decimals unless you absolutely have to. All right, now we find K. So K is what I get when I plug that answer, 1/4, into the function. Yes, I'm going to use the fraction. I know you don't want to, but I'm going to. It's 4 times 1/4 squared minus 2 times 1/4 minus 1. So all I've done is replaced all my x's with 1/4, yeah? What's 1/4 squared? 1/16, right? Multiplying straight across. 1 times 1, 4 times 4. So you get 1/16. So 4 times 1/16. How about this negative 2 times 1/4? I'm going to go a little slower. Negative 2/4. So you're multiplying like 2 over 1, or 2 times 1, and then the 4 times the 1 that's underneath the 2. That'll be negative 1/2. Then minus 1. So this is, let's see, the 4 divided by 16 is really 1/4. So this is 1/4 minus, we said 2 over 4 is 1/2 minus 1. You want to get a common denominator? Okay, what would the common denominator be? 4, so 1/4. Hey man, I'm going back to 2/4 again. 2/4 minus 4/4. So you put it all together. 1 take away 2 is negative 1. Take away 4, negative 5/4. So I'm combining all the numerators. 1 take away 2, that's negative 1. Take away 4, negative 5. Negative 5 over 4. Yes or no on this up to this point? All right. So what do I know right now? I mean, I know the vertex, right? The vertex, my vertex, which is called HK, is actually 1/4, negative 5/4. This is a point, right, on my graph. In fact, not only is this a point, is it the highest point or the lowest point? Lowest. How do you know? It opens up, so it's the lowest point. So this is the lowest point on my graph. I know that right now. What's part C? Oh, part C, sorry. What's part D? Quick sketch. So here comes a quick sketch. All right. And when I mean quick, when I say quick, I mean quick. Where's the vertex? 1/4 is to the right, isn't it? Negative 5/4 is down. Somewhere down here I have a vertex, don't I? To the right, 1/4, down 5/4. I don't care where it is, just to the right and down. And my parabola opens which way? Up. Which means I must hit the x-axis what? Twice. I have 2 x-intercepts. What if this parabola would have opened down? I would have no x-intercepts, so why go set the function equal to 0 if you're not going to get a solution, right? You're going to get an imaginary number or something. So I'm going to list here, I have 2 x-intercepts from this quick sketch. Any questions on that? How do we find them? How do you find the x-intercepts of any function? That's the y-intercepts. Solve f of x equal to 0. Set the function equal to 0. So what's my function? It's that quadratic, right? Negative 2x squared. No. What was it? 4x squared minus 2x minus 1. Set that to 0. And from that, what type of equation is this? It's quadratic. How do you solve a quadratic equation? You can try and factor it. Does that factor? I heard yeah, but does this factor what? To be what? It's not. No? Is it? No? Are you sure it doesn't factor? So what if you don't know? What if you can't figure it out? Use the calculator, yes. What do we have that will solve any quadratic equation anytime? Quadratic formula. That's what I will employ here. If I can't factor it, then I'm going to use a quadratic formula. And I hope we all remember the quadratic formula. Yep, all that thing, right? So x will be, hang in there, I know y'all want to go. Negative b, which will be 2 plus or minus square root b squared. 4 minus 4 times negative 1. C is negative 1 all over 2 times 4. So it looks like we're having what? 4. This will turn into plus 16. 4 plus 16 is 20. So 2 plus or minus root 20 over 8. And now I do need someone to get their calculator out and tell me what root 20 is. It's about 4 point, what? 4.47? Is that what you said? 4.7? We'll say 4.5. We're rounding it just one decimal because we are not, trying to be too precise in this class right here. And now we get two answers from this, right? We get, first we have to do on our calculator 2 plus 4.5, 6.5. Divide that by 8, and what do you get? So we have two answers here. 6.5 divided by 8? 2.5. And then you do 2, take away 4.5, which is negative 2.5, then divide by 8. What is it? Negative? Negative 1.4. Is anyone else confirming that, or just can trust it? Does it seem right? Does that seem right? Doesn't seem right to me. It can't be bigger than 2. I mean, it can't be bigger than 1. This is not right. Something's off. Look, 2 plus 4.5 is 6.5. 6.5 divided by, you were doing them all at one time and not using parentheses. Be careful with that. So point what? 8125. And then this other one? Negative 2.5 divided by 8.
Negative 0.3125.
That looks better. Questions or no? We only have 5-6 minutes left. Those are our two x-intercepts. So watch the way I write this. X-intercept, we know that when I plug in 0.8125, the y-coordinate is 0. This is a point on my graph. I know negative 0.3125, comma 0 is a point on my graph also, right? X-intercepts. Yes. No, because these are points, not...
Oh, that's right. Okay.
They're points. This math notation is confusing. Intervals are one thing. Okay. Single numbers would be with the braces. This is not a single number. This is an ordered pair. This is a pair of numbers, x and y.
But I mean, but it's kind of given that it's a zero if you say x-intercept.
As long as you remember that, that's fine with me. I'm just stressing to you that this is going to be a point. Because we have to put all the information together at the end. I just want to make sure everyone knows what each step, what you're getting. Yes? If you just box these two things, I'd be fine. If you put these, I'd be fine. What else? If they're whole, you couldn't round these. Wait, ask again. If they're whole numbers, what? No, you would never. No, you wouldn't. Yep. Okay. What's the next step? I've done part D. What's E? Y-intercept. For the y-intercept, you just plug 0 into the function. And you get 1. So again, this is a point on my graph. And now I'm ready, right? That's all I wanted? All that information? So let's draw it on a new page. I didn't look back. Someone told me 1. I just didn't even think about it. Is it negative 1? Okay, let me go back and look at the function. Yes, it's negative 1. Sorry. The function was negative 1.
I'm saying there's 1 y-intercept.
Gotcha. All right, here we go. Let me start out with the vertex. So where was our vertex? 1/4. So the question becomes, how accurate do we need to be here? We're not, again, putting a man on the moon here. This has just got to be close. If we say that this is 1, then 1/4 would be right in here, wouldn't it? Right about there? And I'm supposed to, my vertex was that, and then how far am I supposed to go down? Negative 5/4. Where's that? Negative 1 1/4. So if this is negative 1, it would be about right here. Now, in order for me to help you know where that point is, what I'm going to do is I'm going to label the point. 1/4, negative 5/4. And that's something you would want to do on the test also, so that everyone knows your vertex is correct. Now, where are the x-intercepts? 0.8. Where's 0.8? Somewhere in here. Again, getting close. I'm going to label it 0.81250. Where's the other x-intercept? Negative 0.3 something. So how about right here? Right? This is negative 1 right there. So does that look okay to you? Negative 0.31250. And then, any other information? Y-intercept. Where was your y-intercept? Negative 1. You could plug in more points if you wanted to. But what I'll point out here is that if your vertex is the bottom, then if we imagine, boy, that's bad. Wow, okay, that's all right. Imagine that imaginary line through the middle, that's our axis of symmetry. Our parabola needs to look like a mirror image of itself along that yellow line. And it needs to look like a U, not a V. If you draw a V on the test, you're going to lose points, because it's not an absolute value function, it's a parabola. So I'm going to come through here and try and draw this. That's it. By the way, this right here is the axis of symmetry. It's a vertical line. It goes through the x-coordinate of 1/4. Right? If I move out to the right 1/4, that's the line. X is equal to 1/4. The solutions for this section are up. I finished out the solutions for 4.3 and 4.5 last night or something. So you can start this if you like, the homework for this section. We still have more to do when we come back. I'm thinking on Tuesday, we'll at least finish up. I mean, in the first hour of class, we'll be done, and then we'll have the rest of the class to answer review questions. Have a good one. We'll finish 4.3.